This conference will now be recorded.
Cool, thank you. Good morning, everyone, and thank you for joining today. And good afternoon or evening to the folks who are in Europe. Cool. What we have on the agenda today? Today we're going to be talking about our data model for test IO in JSON format. So I think last week we had a quick discussion about what we want, and we were going to bring our request to this table to see what the JSON format should really look like. With that,
Hey,
uh,
Paul,
yes.
it looks like I see on the list, it looks like Rick Eads from Keysight was able to join us today. Sorry, I didn't get a heads up. I didn't get a response back because I think he was out of town until late yesterday. But it does look like he's on the call if we want to ask him about the PCI SIG stuff.
Awesome. Yeah, that was
Yeah, I
also on the
saw that
agenda.
was on the agenda, and I was out last week, so happy to chime in if you have questions at whatever point you want.
Oh yeah, that's also part of the agenda today. So we wanted to talk to the PCI SIG people to understand what the test requirements are. We've come up with a test document around like what the test specification should be for PCI, and I think that would be a good way to proceed. Maybe we should start with the PCI SIG topic first. Rick, maybe you want to introduce yourself?
Yeah, hi. My name is Rick Eads, and I work for Keysight Technologies. I'm the program lead for PCI Express tools for Keysight, and that means I'm responsible for the portfolio of transmit test, receive test, and other classes of tools, channel test, and et cetera. I also serve on a number of committees, Serial Enabling Group, the electrical working group, and the car electromechanical groups, focusing on physical layer test. And then since about 2007, I've also served on the PCI SIG board as a member of the board of directors. So I've had experience with PCIe since the very beginning, from the days of Gen 1 and Arapahoe, if anybody remembers that. Up until most recently, we've been working on PCI Express Gen 6 and trying to get the test spec finished for Gen 5.
Rick, this is John. Thanks so much for joining us. I know it was difficult getting it scheduled, but I appreciate it and hope you don't feel like we're just feeding you to the wolves here.
Oh, no worries. I've got lots of bite marks all over, so what's a few more?
Well, thank you.
Good. Yeah. Thank you for joining, Rick. I think where you can help us is we're trying to understand what where we can kind of integrate into the PCI 6 specification here. We've come up with what we're trying to achieve actually is to come up with a test spec around system level testing for PCI devices, right? So if you boot a PCI device in Linux, like what the behavior should be, what the requirements should be, so on and so forth, right? And so I've taken a look at some of the PCI SIG specifications, but maybe you can share a little more about how PCI SIG defines this today.
So you thinking from a protocol perspective or from a physical layer test perspective? Both?
We're kind of looking at both actually, both the device specifications in terms of like how the system recognizes it, and not so much on the electrical characteristics of things, but to the extent of like what can a system measure. Let's say if we have a system level box of like Linux, right? How do we measure the device? How do we actually look at the device, and how can I qualify that the device is operational and in good working condition?
Well, from a PCI SIG perspective, if you look at the compliance program, we divide compliance into two parts. And all of that compliance requirements are defined in our test specification. So that you can take a look at previous test specifications for like Gen 4. We're currently working on the Gen 5 test spec, and it follows pretty closely as you go, jump the speed from 16 gig to 32 gig. So I'll just touch briefly on the physical layer side. The whole goal of the test spec is to help focus on those things that are interoperability predictors. So things that, if you don't pass them, they could lead to interop problems. So we start with physical layer test, where we want to test transmitter for transmitter characteristics and receiver test. And part of the receiver test does involve some protocol elements, because since Gen 3, we've had a link training, low-level link training communication going on between link partners, where the emphasis coefficients are being shared back and forth to optimize equalization. So we want to know that the link's going to come up good, because if the link is unstable or it isn't operating at speed, then the protocol tests are kind of subordinate to that, because you really want to make sure that those elements are things that you can depend upon from an interoperability standpoint, if that makes sense. Then from a protocol standpoint, we have a number of protocol tests where we try to create certain test conditions that look at and create certain errors. Like if you request a certain number of packets or from the device, you make that communication back and forth, and then you end up sending more than what was requested, or you don't send enough to see that there's proper error handling that takes place. So there is a certain suite of tests that we call our link and transaction tests. Now, you mentioned Linux, and I believe a lot of some of the configuration tests are built around an assumption of a Windows OS, and I think the PCI-SIG for Gen 5 was investigating coming up with a non-OS specific version of that would also run in Linux, but I don't know what the status of that might be. For more detail on what some of the protocol tests are, it might be worthwhile to bring in another one of our directors, Richard Solomon from Synopsys, who's an expert on the protocol side and can go over in more detail with you what some of the tests are in greater specificity. But overall, the idea is that we've defined a number of capabilities within the PCI Express specification, and we've gradually added to that. For example, we added lane margining as one thing. I'm not sure if you were inferring that, but we do some tests as part of the PCI-SIG compliance program, where we test just to see if the protocol that controls lane margining, that gives you a sense of how much margin you might have, either on the voltage or time scale at the receiver level on a lane by lane basis, to get a sense of how much margin you have in an operational link. And that can help a vendor determine whether or not, for example, that through the variances of manufacturing tolerances, that their system is ready to ship. So that's kind of a brief overview. Do you have any more specific questions?
So yeah, thank you for sharing. So when I was looking into the PCI 4.0 compliance requirements on the SIG website, like I came to a conclusion pretty quickly. Like most of these tests are being done by very specific devices, right? Like either you have to use a Teledyne kind of device, or like some sort of measurement device that Synopsys is providing, or something like that, right? Is that an accurate statement though?
Yeah, as far as the suite of tests that go, the link and transaction tests are usually done with a tool called a protocol exerciser. And so the exerciser interacts with the device as a link partner, and essentially can mimic a lot of different system configurations to work the system through various configuration tests for how many different endpoint configurations, different lane lists, things like that, and make sure that the root complex or root port system is able to accommodate all of those. So it's an easy way of going through multiple scenarios with the device under test to see that it works properly. I think there's also a configuration test that we run as part of the as an application that runs on the OS, but I don't remember the specifics of how that is. I know that there was one test that we ran on the OS that looked at some of the capabilities of the PCIe ports, that didn't require equipment. But yeah, we do use an exerciser for a number of the protocol tests. That's a big part of the protocol compliance program.
Cool. By the way, are these documents public information, or is this something that you have to be part of PCI SIG in order to read these documents, to have access to them?
Yeah, that's a good question. So the test specification documents are publications of the PCI SIG to the PCI SIG membership. So I believe that you have to be a PCI SIG member in order to access the docs.
Interesting. Okay. Because I trying to figure out a way how to share this across to this forum, because this is an open forum, right? So we probably want to be extra careful about that. Perhaps I can tie up with you and some of the other folks at PCI SIG how we can make this a more open specification at any rate, or even bring this into the open specification.
Yeah, I mean it's worth discussing, because we have liaison agreements that we've set up with other entities where they have had a desire to share documents, and it's more than just the sharing. There's a IP policy that the PCI SIG adheres to legally. So in order to have the IP protection, it requires you be a member of the PCI SIG to be part, to basically sign off on the RAND agreements that we have in place. And so it's really more of that is a greater concern to the SIG board. But if you want to entertain, there's different levels of interactions we can have with a different standards body through the creation of a liaison agreement. And if we can come to terms on that, that's a possibility as well.
Yeah, I mean, I'm looking at a document, and I think a lot of the things that we're chasing is very similar to what you guys are have listed in this document, in terms of like looking at link speed, looking at link width, looking at maximum supported speed and things like that, right? So there's a whole bunch of stuff in here that's probably similar and overlapped, and it'd be great to try and figure out how we can wrap this around the PCI SIG spec in the first place and make it open sourced. Cool.
Certainly, we've spent a lot of time, developing it. So it's in my opinion, if you're leveraging PCIe technology, it's a good place to start. I know some standards organizations have, required their membership to be members also of the PCI SIG to make it easier for them to have access and leverage those documents. But like I said, it really depends on what you want to see, what you want to be able to share, and looking at that in specifics, and then working it through with the PCI SIG board and then the executives in charge to see, what's possible, within the scope of what we've done with other organizations.
Sounds good. Thank you. Anyone have any other questions for Rick?
No, just thank you for the introduction, Rick. One thing I would say is, when we originally got started, a lot of us were sort of the opinion, we want to be careful. We're not trying to reproduce or recreate the PCI SIG spec, right? Like that's a very good comprehensive document, and it addresses things that will always be out of scope for us. Like there's going to be something in the PCIe spec that says, you need to meet these physical requirements for the tray, right? Which we could never validate unless you get out calipers or something like that, right? There's going to be things that say, you must support, X watts of power draw for sustained time, right? Like once again, not something that I think we would be looking for. The way I was looking at this, Paul, is we want to make sure that when we have a PCIe device or PCIe motherboard or host, right, or a PCIe switch that's part of an OCP product, that it's supporting certain software features so that we can leverage those. And those might be, I support calling that PCIe, reset command from the kernel, right? Or I support the AER injecting of errors, that particular driver through the kernel, right? I've got access to those AER registers, and those are floated up to me, right? To make sure that like all of those PCIe features are supported, right? So that we can leverage those for like test and device health.
Yeah, absolutely. I think that this is a good starting point for us to kind of take a look at what the SIG is doing as well. But yeah, I do completely agree with you, Dan. I think that it's what we're chasing down, and the PCI SIG test specifications, like I mentioned earlier, is like super in detail, and also might have a lot of things that are more pertinent to the electrical side of measurements, right? Like measuring band capability and things like that, right? So there will be a little bit of overlap between what their requirements are and some of the things that we're looking at, right? Like they're measuring widths and things like that. But for the most part, I think we're after a different piece of the puzzle here in terms of what we're trying to get the system to recognize and what we think should be the spec requirement in terms of taking an OCP device and throwing it against a test suite, right?
Yeah, for sure. I mean, I look at the spec as that's to say I'm building a motherboard, you're building a network card, right? They work together, right? We both met that spec. Whereas I think this effort is more around saying, okay, these PCIe features are exposed up to the level of resolution that we're looking for so that we can gauge sort of the health of our products in both manufacturing and, in production without necessarily requiring specialized test equipment, right? Whatever we can expose up through the features of the device.
Right, and if I'm not mistaken, I think they use a specific script that they kind of measure a system against. Like there's this PCI ECV app that has been built for measuring some of the characteristics that they're looking at as well, right? So
Yeah, that's right. PCI-CV. That's the application I was thinking of.
cool. Thank you for sharing. Thank you for the input, and thank you, John, for bringing Rick to this table. We'll continue that conversation. Vincent, do you have something to add? You're unmuted.
Yeah, I was actually going to go along the lines of what Dan was talking about. First of all, thanks a lot, Rick. That was really enlightening. I actually hadn't had a chance to go deeper into the PCI SIG, but I was intrigued as to whether what we're after here that Dan summarized would be a good complement to PCI SIG, or do you see it as really a different track? And when I look at some of the documents I could find, I can see that I actually had a question around, is this really for bench testing as part of the design validation of a product, or do you have applications of PCI SIG for volume manufacturing testing? I was curious about that. And integration testing, I should say, integration testing.
The compliance program focuses on two things: compliance and interoperability testing. And I contrast that to some of the other standards that focus on device testing. So for us, within the PCI SIG, we really want to test finished products, products that need to be able to demonstrate interoperability. So the things I talked about before, which were the need to validate against spec for physical layer TX and receiver performance, the need to validate against protocol requirements using an exerciser for establishing capabilities according to the PCI SIG protocol, are all, I'd say those are two of the three main components of the validation program. The third point or part of it is interoperability testing. So a vendor would have to demonstrate that they're able to interoperate with other devices at a PCI SIG sponsored event to the tune of, say, 80%. So if there were 10 host platforms, for example, they would have to interoperate with at least 8 of them in order to achieve what the PCI SIG would refer to as compliance and receive the opportunity to list their product on the public PCI SIG's integrators list. So the standard itself is a high volume manufacturing focused standard. And on the board, we have a lot of considerations that we take into account to try to streamline the specification to make it applicable to the 800 or so members of the that form the PCI SIG membership body. So many of those vendors are focused on low cost, high volume manufacturing capabilities. So from a testing standpoint, the tools that we provide in the test specifications are geared toward helping vendors, once they have finished products, to take them to a SIG-sponsored workshop event, to have them be tested according to each of those 3 requirements, and then they can list them as being independently verified or validated on the PCI SIG website. Now is not necessarily going to be an exhaustive set of tests, right? It's more of a check and a balance to make sure that when people say they have PCI-SIG or PCI Express capabilities in their devices, that there's some independent body that takes a look at that and says, yeah, for what we can tell, what we think are the big interoperability predictors, this looks okay. I know from talking with some motherboard vendors, they have much more exhaustive tests that they run for multiple lanes, for multiple devices that they develop as specialized tests. Test vendors have more exhaustive test capabilities in their equipment, both on the protocol analysis side, receiver test and transmit test capabilities, and then the standard itself. I mentioned lane margining. That's a big element of providing vendors with a way of testing 1,000 motherboards in a rack system, for example, and getting a sense of how they interoperate, or how much margin they have in a production environment where the manufacturing scale has been ramped up. We don't go into a lot of detail on testing the lane margining capabilities of devices, except insofar as we do look at to see that the devices at least support the protocol.
Great. Yeah, I think there's definitely something to look into further into that interoperability element, and I'll let Paul follow up with you offline to clear the question on the openness. But thanks for the details.
Sure.
Cool. Thank you. Guess we can proceed to the next topic on our agenda, which is the data model for I/O and for testing. I think last week we all mentioned that we wanted to bring our JSON format to the table and see whether we can reach a consensus on how the JSON format should be.
Paul, maybe one more comment before we leave PCIe SIG. So I was just looking at some data from our own testing. We do a lot of PCIe devices. We don't sell those devices to other people, but we do still submit to compliance testing because we want to make sure, if we did buy an off-the-shelf motherboard, we suspect that device would work. So we're finding about, a small percentage of the problems that we have in actually compliance testing, right? It looks like, without going into the specific numbers, most of our problems that we find are after that. And they primarily come down to, as Ed was mentioning, purse timing programming errors and link training sequence errors. So basically, they're fixable in software. But we typically don't find all those weird edge cases and where we've run thousands, right? And those are sort of the tools that we're looking to make sure that we've got here, right? Just so that we get that weird error condition, or you've got maybe, a manufacturing process that's slightly different on some version of the cards from other cards. That's where we'll find some of those things where the equalization and timing parameters that we've got, aren't quite perfect. So those are some of the tools that we're looking to add to that OCP spec here. Anyway, end of diatribe.
No, thanks for that input. That's pretty critical as well, right? Like, it really helps put this perspective why we even are pursuing a separate test specification from PCI SIG, or how to even look at the difference between what we're doing and what PCI SIG has today as well, right? Cool, thank you for that. Back into the data model. So actually, Dan, do you want to get started, or Vincent, do you have your format?
Actually, Vincent, if you're ready, would you mind going first? I'm working on some technical problems here.
Oh gosh, I am so not ready. I'm not ready to do justice to the topic.
If you're not, I can go then. I mean, I can do it.
Yeah, I pulled some information, but ran out of time, and I don't really want to shortchange this important topic. I mean, I'm happy to give the high level overview, which is really like a 1 minute highlight of what we do, but I don't know if it's really going to help shape the JSON output discussion. I mean, I can start there and let you take over, Ben, if you need a little more time, or if you want, you can dive in.
Well, I can show you what I put together. And I think my level of effort was probably somewhat commensurate with yours. Paul, you can make me a presenter. I'll share my screen here real quick.
Let me figure this out. Perfect.
Yeah, I'm sorry. I'm still not familiar with this software. Can you guys see what I've got here? Paul, are you guys able to see my screen?
No, actually.
Nope. Okay, let me try again. It says what to share, entire screen. Anything?
No,
Not yet.
not really.
Let me try a window and see if that makes a difference. Any luck there?
No.
No, and
Okay.
I'm gonna guess it's asking for a permission somewhere. That's gonna be
Yeah,
my
and I don't
guess.
see that. So that's what I was expecting. I just got a new laptop, and on the Mac,
Yeah.
you need to give it accessibility features, right? Let me
Yeah.
try this. Paul, can I share the Google Doc with you and you present for me?
Sure. Let me
Okay, who should I send it to? Paul NG at FB?
fb.com. Yeah, that'd be perfect.
Okay.
Or Tobias or Yen, do you have a format that you like to present as well?
No, sorry. I don't have anything to share today now.
Okay, let me know if you got that, and then I'll unfortunately have to ask you to do your best Vanna White and flip slides for me.
That's fine. That's what I'm here for. Let's see.
Yeah, it's probably a dated reference. Nobody probably knows who Vanna White is anymore.
I think she's still pretty popular. Can everyone see my desktop?
Yes.
All right, perfect. Assuming next slide then.
Yep, let's go to the next slide. So we talked, a little bit about format versus schema, and we've decided, as far as our format goes, we are all in love with JSON, right? And then I wanted to talk a little bit about the schema and give you guys a little bit of background on what it is that I'm showing here today. So we've been through multiple schemas at Google over the last, 8 or 9 years, and the one that we've kind of finalized now is the one that we plan to open source, which is going to be part of our Melton, shared diags initiative. And for this, what we're really aiming to do here is to make sure it works with our internal systems, it works with all our different, manufacturers and vendors so that they can also go and sort of absorb this data. And then some of the things that we've done to work around, the limitations of JSON, right? So if you go to the next slide, the first question, we had last week was, is there any industry standard that we can adopt, right? And I actually did a little bit of research on Sunday to see if I could find anything here. And the main thing I found was still IPC 2047, which we talked a little bit about. It's not a free specification, unfortunately. It's not openly licensed. You have to pay for it, right? So I didn't want to go too far into their details. I want to respect their IP here. But it is geared towards PCB level tests, but I would say that it definitely informed the structure that we came up with, right? It's actually pretty well done. It was like 20 or 30 different companies there, Agilent, Keysight, some of the other vendors, NI was in that, a couple of the CMs were involved. It's a pretty good spec, but it's old, it's dated, right? It was XML based, but it has a lot of the key concepts that we're looking for here. But Melton and its result structure is inspired by that. We've simplified it a little bit, right? So in the next slide, we'll talk a little bit about what is the Melton schema, and I'm not going to go into every field. Obviously, I did paste the detailed, specification at the end of this doc, right? But essentially, what we've got is we have the concept of a test execution, which is something that you're running, right? And then that's broken down into individual test steps, right? A test step is generally used to represent like one aspect or one attribute that you're trying to evaluate as part of your test, right? It's not necessarily used for progress or something like that, like step one, step two, step three. It's generally used for, say, I'm looking at PCIe retraining statistics, or I'm looking at PCIe correctable error statistics, things like that, right? That would be how we break down a step. And the primary use of that step is it takes our measurement data, which consists of sort of measurements, which is just like a discrete observation in time, and then a measurement series, which is essentially a plot, right? Which could be a 2D or 3D plot. And then associates those with diagnoses, right? Which are observations we made about the product. So we may have something like, a measurement that says like number of PCIe correctable errors, and maybe that's 65,000. And then we would have a diagnosis that says, PCIe retraining rate or correctable error rate unacceptable, right? That's sort of what the step does. In addition to that, we have an error format, and we have what we call an artifact extension. And that artifact extension is essentially just like a void pointer. You can put anything in there, right? That's for whatever weird stuff you have that may not fit into the spec. So an example of what this may look like here is this is a real test called MLC, which is a latency test between chips. And this would be basically for, a 2-socket or 4-socket server. What this test is doing is it's measuring the bandwidth between the nodes and the latency. So this would have 4 steps, right? It might be intranode bandwidth and internode bandwidth, as well as inter and intranode latency, right? And then we would have the measurements representing those, the diagnoses that we generated, and then the hardware that it's tied to. And the way we specify what that hardware is the dev path that we discussed earlier, which is sort of that canonical string to represent a device in a graph. But it could be anything, right? It could be a PCIe ID, it could be a PID vid, and it could be whatever you want to put in there, right? But that's what it means to us. Next slide. What I wanted to talk about here is we've got sort of 2 things. We've got the concept of data at rest and then data in flight, right? For lack of a better word, or data messaging. We call them DTOs, data transfer objects, right? And it's to get around one limitation of JSON, which is to be valid JSON, you have to have a top level element, right? So if we have a test that runs for, 7 or 8 hours, like we're trying to, figure out like PCIe reliability over time, for instance. Well, we can't run that test for 8 hours and at the end drop like a giant JSON blob of like 8 gigs, right? Like it's just too much stuff. So to get around that, we're using the LD-JSON specification, which I actually just learned was called that. I've been calling it JSON-L, which is wrong. And you can read about that spec here, but essentially all it does is provide a streaming solution for JSON, right? And you can see a real world example below of the test that I just highlighted above graphically. And you're not going to be able to see this. It's an eye chart, right? But what you'll see is basically each one of these lines, and it's line wrapped a little bit, is like the start event. One might be a step start event, and then we have attributes to go down with that. And that way we can stream these things out, whether you're streaming out to a database or standard IO or whatever it happens to be, right? And then the thing that collects that, whether that be OpenTest or Contest or whatever it is, can then go and turn that into the at-rest results when it's done. Next slide. And then this is basically all the details of the message, the fields, and things that we have standardized on, right? So this is what that schema looks like to us. There's about 3 or 4 different ways you could achieve the same thing. But what we're really trying to get out of this is a way to interchange the results with multiple consumers, right? To make it so that they don't really care about protocol. You don't necessarily need to be able to talk RPC or gRPC or protobuf or Corba or XML or SOAP web services or whatever your favorite interchange technology du jour is, right? We try to keep that as basic as we can. And then these are all the different attributes that we've got that kind of make that up, right? But it's basically, what are you testing? What did you see? What did you determine? And then what was the device that was tested? And that's sort of the raison d'etre of this whole thing. And I think that's all I got, but that I thought would maybe be a good introduction to what we've done, and then we could look at what some of the other folks have done, right? And then start kind of comparing and contrasting and hopefully finding, sort of a common ground where we get something that we can introduce into all our test executives or processes so that we can really start sharing diagnostics.
This is super useful. Yeah, trying to digest the information here as well. It looks like you guys have
Yeah, can I ask a
given us
question?
Yes, please go ahead.
Awesome. So where exactly? Sorry, I know you explained the bigger picture structure of all the things before, and I probably just forgot. But like, can you repeat really quick where the diagnosis result is computed? So obviously the measurements are collected on the device, right? Is the diagnosis also computed there, or is that further up?
It can be. So in Melton, there's a concept of two types of diagnostics, right? There's an on DUT diagnostic and an off DUT diagnostic. I would say the majority of our diagnoses are actually computed off DUT,
Yep.
right? Generally because the limits come from off the DUT,
Sure.
right? But in some instances, we do it on the DUT because we're sending so much information that it's just too chatty to do it that way, right? We're sending too many messages back and forth. Like an example would be like if we're monitoring voltages and we want to look at, a 100 millisecond dip. Well, I can't send all that, right? So I have to compute the diagnosis on the DUT, for instance. So we support both, but we prefer off DUT.
Yeah, that makes sense. Thanks.
Yeah, we're pragmatic. You just can't always do it.
Yeah, that's great. I also have a quick question. So I understand the JSON messaging format and now this data structure. I don't exactly understand how the two tie together. Can you maybe talk a little bit about that? Is that some kind of validation that the JSON format matches the structure? Or I don't know, maybe you can talk more about that.
So, if you look at JSON, it's essentially a whole bunch of key values, right? Well, to diagnose or not diagnose, that's the wrong word, to ingest that, right? You still need to understand what those key values represent, right? And that's where I'm trying to make the distinction between, well, your messaging format is JSON, but you still need to understand what your message is and what it means, right? What we don't want is a whole bunch of different diagnostics that can just output anything, and then we have sort of a mapping layer behind the diagnostic, right? We think that the interoperability really comes from having a common messaging format in addition to a common schema.
Yeah, absolutely, I agree. I think my question there is, do you have something kind of similar to XML schema where you validate that this JSON format actually matches the schema? Is that done automatically, or is
So actually, no, I misunderstood your question, and that's a great question. Not that your other question that I thought you asked wasn't. But no, so we don't actually generate the results natively in JSON. We generate the results in protobuf. And then from protobuf, we can convert to anything. We can convert to JSON or XML or about 4 or 5 different other formats, right? But the validation that we're outputting valid data is actually done at the protobuf level.
Okay, great. Yeah, thanks.
Yeah, the reason why we do that is for Melton, it's a language, well, it's not completely language agnostic, but essentially you can write your diag in 3 different languages. You can write in Python, you can write in C++, and you can write in Go. And somebody is working on C, but it doesn't work yet. And what that basically allows you to do is all this common back-end stuff we only wanted to implement one time, right? And that's actually implemented in the protobuf format. So regardless of what language you're using for diag development, you get consistency across all those different languages.
Okay, great. Yeah, makes sense. Thanks.
Cool. Thank you for the great introduction, Dan. Anyone else? Any questions before we pass the ball over?
How do you keep track of the life cycle, the state of the DUT? Where in the steps it's executing? Is there a higher level hierarchy here somewhere?
It's actually not. So for the state of the DUT, like where it's at in the test, that's why we can why we stream, so we can kind of see like, well, how far along are you? Like 30% of the way done? Are you 40 or 50% of the way done? But as far as like the state of the DUT, like is the DUT rebooting? Is it in the middle of a process? Like how many processes are running and things like that? That's typically done through another Melton diag, which we call a system monitor, which is very, very long running. And that might interface to the BMC, or that might interface to some ONDUT logic or Jesus, which we've talked about a little bit. And what typically happens is that monitor is looking at everything, and then we have other diagnostics that are applying stimulus, right? Which might be like, okay, now let's load the processor down as much as we can. Let's run all these different memory tests. Let's feed on the disk drives, right? So the two diags sort of work in parallel. One monitors state, and then one tortures the device.
Oh, okay, that makes sense.
Thanks, Dan. This is pretty comprehensive. I'm glad you went first because it sounds like this is well beyond what I had in mind around PCIe. More explicitly, this seems more like the communication substrate between the executor and the actual test runner itself. Is that right?
It is, and I was going to actually use the PCIe example rather than the MLC example, but it was Sunday night. I kind of ran out of time, and the PCIe thing collects like a million things, so I didn't want to use that as an example. But like, I guess the main message here is if you look at this messaging spec, like it doesn't know anything at all about PCIe, right? Uh, it lives above the test. What it really says is there are things, you're measuring those things can pass or fail or generate errors, right? And then it's up to you to say, okay, how does your test fit within this particular format? And then if it can't fit in the format, you get the get out of jail free card of the artifact extension, where you can say, I'm going to put, whatever crazy stuff that I want in there. And typically when that happens, those are photos, which are not necessarily data that we analyze like in aggregate, but it might be something that we're interested to have as part of the test result, right?
I was wondering, do you have, so Fava has a very similar concept of this background monitor that runs for the duration of an entire test sequence, and it's actually agnostic to the on-DUT tests that are run. Is there any form of synchronization that happens if, for example, you're monitoring the PCIe, stats? Is there communication between the sort of global monitor and a specific test that may be verifying, a NIC, grade or AER or whatever PCIe is sharing? Is that
There
part of
is
the spec?
in Melton. Melton contains, obviously, this isn't data related, this is more Melton related, but Melton has very low level primitives, right? So, what it has the ability to do is send a signal to an executing diagnostic, and it literally is a Unix signal, right? Where you can say, pause yourself, resume yourself, check on the status of yourself, things like that. But the actual synchronization would be up in the test exec runner or whatever is, sequencing your test. That's the thing that provides like sort of first principle concepts like this is a semaphore, or this is what we call a critical section, and then certain other diags that we want to rendezvous so that they run at a certain time together, right? But by far the most common example of us wanting to do some type of synchronization is that we're loading down the device so heavily that it can't respond any longer, right? So we want to stop that test for a minute, get the results and then resume it, right? Or otherwise we start to get RPC failures and things like that. This has gotten worse as we've gotten better and better and better at loading the device, right? And we're now to the point where, we can pretty much we can kill it, right? And it took us a while to get there, but now we think we can generate the worst case workloads to find, SDC events and things like that that are difficult to detect otherwise, right? If you're just running like, memtester or something like that.
Yeah, I guess one more thing I want to ask or I'm curious about is those measurements, those discrete measurements. Do you approach them as logging those no matter what, or are they typically an inherent step or part of a diagnostics run. And what I mean, I don't know if that's clear.
Well, so let me maybe answer the question and tell me if I missed it. So measurements always come out of the diags, right? So like we have the concept of a verbosity flag that you can pass to Melton, and that changes the amount of logging that's emitted, but it doesn't change the amount of measurements that are emitted. Like those always come out regardless. Because generally, like if we're emitting something as structured data as the measurement, other than it just being like a console log or something like that, it generally means that we want to collect and analyze it over time.
Yeah, I think one of the use cases I'm thinking of is we have some tests that are written in a way where they locally monitor conditions and will only emit the pass fail based on sort of implied criteria, right? And so those elements are measured, and I'm thinking sort of about the PCIe. It's collecting a measurement effectively, but it's not logging the measurement back into a database, so to speak. And I think it just makes me, because it sounds like based on what you showed, that your schema is basically your database ultimately, where everything gets logged, and it's very much like a RESTful API where everything's basically being written back into the database. And I'm trying to wondering if sort of that logic of collecting, observing a PCIe value should always sort of be part of this. If there's any use case where it should not be logged into sort of an ongoing
Yeah,
database.
I mean, there are for sure, right? Like certain diagnostics, I can say, they might be sampling like every 10 milliseconds or something, and we don't drop all of that back. We might drop the moving average or something back, right? But like in that case, the diag, I guess it's the implementation of the diag that does that, right? But there's nothing specifically in Milton right now. There's like not even a binary flag at the moment to turn on or off measurements, right? Like it would be easy to add, but it's just not there right now.
Mm-hmm.
So right now, like if we get a measurement back, we believe that that is intent that you specifically wanted the system running the test to record it, right? Now, what that system does with the data, it could do whatever it wants. It could throw it away. It could pick every third one. It could, obviously that decision's up to it, right? We try to record as much as we can, but it's just in situations where, either one, it's just literally too much data and it's not that interesting. And that would be generally when we're looking for very short-term time, events. Like a good example might be like, let's say that you're looking at a PCIe lane and you're wanting to measure like jitter and wander, right? Well, you don't necessarily pass back, all the discrete observations, for instance. You may only pass back like, this is my wander measurement or this is my jitter measurement, right? And that's what we would actually put is the thing that like the engineer would be interested in.
Yeah, and where I was going with this is sort of really not seeing enough in the industry of sort of a smart approach, the is it a protocol or it's just a spec, but the smart attributes sort of being logged in some form of ROM, accessible as part of the device or what's being monitored. And sometimes, and that goes along what Rick was talking about. If we could, in some cases, have the full history of what a component was tested in previous, iterations or step in its manufacturing or validation process, that could be extremely informative. When you get the component, you can actually get inherently sort of the history of its test, as we do with Smart, and get pass that along, and that's super useful to have that log. So that's kind of where I was going with this, with logging that. But obviously, that's living in your database. It's not something that's going to be part of sort of the memory of the system.
No, there are some instances. I think you hit the canonical one, right? Like smart data. There's some DIM information that does get written to, the SPD and whatnot over,
Mm-hmm.
how many PPRs were attempted and things like that. So there's definitely, prior art like in that area. But I think what we're looking to do is for when you just don't have that onboard storage or there's no place to put that, we put this in our database so that we can kind of correlate, hey, we're seeing something in the data center. Let's look back at manufacturing where we did more tests than we would do in production to see if there's anything that looks wonky there.
Yep.
Cool. Vincent, did you want to present or anything today?
I'd want to ask actually whether we want to, because that was not my understanding. So I'm glad Dan went first talking about the messaging itself between, I can take on doing something similar to what Dan did for the case of Fava. I was actually going to present specifically how we approach PCIe itself, just, and it is not as, it wouldn't have as much detail as sort of the messaging API itself. So I actually definitely like the direction of talking about the messaging and the schema as it relates to the test executor and test runner. But I wouldn't really have, I don't think I would do it justice in the few minutes to talk about Fava, itself. Other than mentioned, similar to using protobuf, we use the Apache Thrift RPC, and that gives us some level of decoupling, but that in itself is not super interesting. So short answer, Paul, is probably not today for me.
Cool. No, I agree. Actually, to be honest, I'm looking at Dan's spec and it's kind of blowing me away as well. I'm just kind of thinking about how we can integrate it, but something.
Yeah, I think the question is really for the group, right? So the question is, how could you integrate it, right? Or is this even the path we should go down, right? Like, to completely honestly, if you look at everything that we've done in Melton and all the things, like the code isn't ever, I don't know what the word is, contentious, right? But man, this measurement format took us 6 months to hash out with 79,000 different people involved, and it was almost a religious argument, right? And we've been there, we've done that, but now like to reach consensus across multiple groups, right? I think the burden is high, right? What I would hope is that what we've done here has a level of fidelity that you could move it to any other internal format, right? And you don't lose anything there. That may be a big assumption, right? But like, I think the question for the group here, Paul, moving forward is this the direction that we want to try to go for standardization? And if not, then where's our interoperability point? Because at some point we need to define that API, right?
Yeah, I agree. Realistically speaking, like I'm looking at this JSON format and I'm thinking about it like this is a very high level of information that's being broadcasted between like a storage, like basically between the device itself and whatever is testing the device, right? Like it's kind of interesting because I've seen test executives that pretty much just return error codes and that's pretty much it. Or I've seen test executives that give a high level of detail in terms of like what the test steps are and never really like had a format around it, right? But this is really interesting because this really puts into perspective like what Vincent was saying earlier, right? Like what is our messaging protocol between the executive versus the DUT and how do we actually store this in the long run, right? So this is something that is kind of thought provoking on my side, at least.
Yeah, for sure. And I mean, that's not to say that we don't have diagnostics that just return pass or fail. Like we do. Like not all these fields are always used, but if you do need to send back detailed data, like sort of our line in the ground would be is like, we believe that you can take any type of test data and put it in this format, right? And we haven't found a contrapositive yet. I'm sure if you like went out of your way, you probably could, right? But when we do run into those conditions, like we had one for screen brightness, right, where they wanted you verify the uniformity of a screen, right? Well, that's where that test artifact extension came in, right? And they were able to do it that way. So that would be another example where you could go and you could collect data. Now, can we do anything with that? No, we can't. It's a void pointer, right? You would have to write something custom to analyze that. Whereas, everything else in this, it's sort of standard CPK, gauge R&R, statistical process control stuff you can do with this data, right?
Yeah, this is good. Do you mind if I put this into the meeting agenda so that everyone can have a look at this thing in a little more detail? I think it's when I started looking in detail into the JSON itself, it was really helpful.
Yeah, no, I think for sure, definitely you can do that. I did go through it and tried to sanitize all the product names out of it I could. So sometimes you'll see like redacted where it had like an Intel CPU or something that might
I
not.
didn't notice that part. Yeah.
Okay, yeah. So I removed some of that stuff just because I don't